Welcome again to this new Raka and Boro tech tutorial. In previous tutorials, we have seen many ways on how to trigger an action and how to propagate that action to a variety of systems. Now, let's get physical. What about controlling an object that is not directly within our reach? For example, anything that is connected to an electric power source. Let's say a gate or a door, some kind of motorized device or a simple light. So sit back because switches are coming on our aid. What is a relay? A relay is an electrical operated switch. Let's see the advantages of using a solid state relay. We will be using a solid state relay. Since we will be working with an alternate current, we are able to use this kind of devices. And we will be applying it to the simple things. We will be creating a power switch with 4 outputs. So this is the diagram. As you can see, it has very simple layout. The power supply and the ground are connected to the transformer input. The output, as black and red, will be supplying energy to the node MCU and the relay board as well. Bear in mind, this is very important. You will have to adjust with the driver the output to 5 volts. Channels 1 to 4 from the relay board will be connected to the node MCU pins D1, D2, D5, and D6. And last, you will have to connect the power supply to the light or the outlet, and to the relay switch that will be closing or breaking the circuit to turn on and off the lights. Now, if we go to the Arduino code, we will find that it's very simple as well. We will include the Wi-Fi and the UDP libraries like we did in previous projects, set the Wi-Fi credential to log into the Wi-Fi and set the port as well. Please check this tutorial on how to enhance the code of this node MCU configuration to automatically set the Wi-Fi credential if the port are not able to connect right away. Configure our initial state for our pins as false. In the setup method, we will define the mode for D1, D2, D5, and D6, the serial baud rate, begin the Wi-Fi connection and wait until it's connected. And finally, begin the UDP library. In the loop method, we will check if there is an incoming UDP packet. We will read the packet and convert it into a string with the help of this auxiliary method. Depending on the signal content, that will be switching on or off the indicated switch. Once the signal to the pin is sent, we will send back a UDP signal with the status of all the switches. And we are ready. Once all the pieces are connected and the code uploaded to the Node MCU, we can test our creation by using the short Node.js program we built for the Node More login series, the UDP client server, basically by sending you the UDP signal required by our creation. You can find this code in the GitHub URL in the description. In the next part of these switch tutorials, we will explore different ways we can use previous tutorials to build a device to control these switches by changing their code a little bit. See you in the next one and have a good one. Upper left light on. turn it off.